Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on December 11th, 2025, just yesterday. It introduces an open-weight Russian hybrid reasoning model with an efficient speculative decoding pipeline that makes generation about 1.85 times faster, while still supporting detailed step-by-step reasoning traces. The paper is titled T-Pro 2.0, an efficient Russian hybrid reasoning model and playground. And as we will see later, the mix of tokenizer design, reasoning data, and fast inference has really exciting implications for practical Russian language applications. Figure 1 shows the public demo interface that makes the model's hybrid reasoning behavior and speed differences tangible. The large central pane displays side-by-side answers from the two systems, so users can compare content and reasoning style directly. The left settings column lets users set prompts in basic limits, like temperature and token budget. A narrow strip near the bottom reports token counts, speed, and time, which connects the visible answers to concrete latency numbers. Figure 1 focused on the demo experience, and Table 1 now quantifies why the new tokenizer matters. The table reports average tokens per word across several Cyrillic languages, where a token is the basic chunk the model reads. T-Pro shows the lowest value, so it encodes text more compactly than QN3, GigaChat, or RuAdapt QN3. More compact tokenization usually means faster inference and cheaper context use without losing information. Table 2 shows how much the speculative decoding stack actually speeds things up across several Russian benchmarks. The speed-up columns report that generation becomes roughly twice as fast in both standard and reasoning modes, which means users wait about half as long for answers. The acceptance length columns show how many draft tokens in a row the verifier typically accepts, so values around 3 tokens mean the draft model usually gets short chunks right before the main model steps in. RU Code Evil and C Math stand out with especially strong acceleration, suggesting technical and math-style content is particularly well suited to this decoding scheme. Table 4 compares T-Pro 2.0 with other large models on Russian knowledge and dialogue benchmarks. Across Mera, Memoramu, and ROM MLU Pro, it matches or slightly trails the very strongest proprietary systems, which means the core knowledge of the open model is competitive. In Arena HardRu and Wild Chat HardRu, which are head-to-head chat battles judged by another model, T-Pro scores over 90 in one arena, clearly ahead of most open baselines. Its Wild Chat HardRu performance stays in the 70s, so chat quality remains strong on harder, more natural prompts. Compared with similarly sized open models like QN332B, the gains are especially clear on dialogue metrics, suggesting the instruction and preference tuning work well. Figure 2 shows that the new tokenizer chops Russian text into noticeably fewer pieces than the baselines, so the same sentence becomes shorter in token space and cheaper to process. The top left panel illustrates T-Pro, where the 220-character input becomes only about 55 tokens. The top right panel with QN3 breaks the text into many more colorful chunks. The bottom two panels with RuAdapt QN3 and GigaChat sit in between, which confirms that T-Pro achieves the tightest Russian compression of the group. Alright, to wrap up, the key idea is that T-Pro 2.0 shows how careful tokenizer design plus reasoning-focused training and speculative decoding can deliver fast, high-quality Russian reasoning without huge model sizes. The open weights and datasets should really catalyze Russian language research. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.